Hello, guys, and welcome back on another video on artificial intelligence. In our last video, we have seen what is minimax algorithm. Now, let's understand how to use minimax algorithm in your code. We are going to see the algorithm as such. Let's also look at some common terminologies used in this algorithm. As we know already, minimax algorithm is used in a two-player game. One of the players is called the max and the other is called mini. Max player moves first. At the end of the game, points are awarded to the player and penalties are given to the loser. Let's say in our game, winner will get plus 10 and loser will get minus 10. And in case of draw, no one gets any points and it is a 0. First term that we will use in our algorithm is SO, initial state. In tic-tac-toe game, this indicates the completely empty board where all the 9 boxes are empty. S means the current state and player S indicates the player who has the right to make the move in this state. Next term is action S. This refers to the set of legal moves that a current player can make in a current state in the tic-tac-toe game. This will refer to the number of empty boxes on the board. Next is result, which is SA. In a state, S player of S made a certain move which was described in action S. Because of that action, we will have a new state right now, and this particular state is depicted by the result, which is SA. We have a term terminal S. Every time player makes a move, terminal test is run to check whether the game is over. If someone has won or is it a draw, then a test will return true and the result of the game will be evaluated. If it is not, then the test will return false and the game will move on to the next state. Then finally we have utility. SP. This is also called the objective function or the payoff function. This defines the utility or the final result of the game that ended in the terminal state S, which was last played by the player P. This utility function can come in any form. Usually, if the player wins, they will be awarded a positive number as utility, and if they lose, then they will be awarded a negative number. Why? These games are a zero sum game, and as the name suggests, it implies that there can't be two winners in this game. When one player wins, the other loses. When you add all the final state numbers of plus 10, minus 10, and 0, it all adds up to 0. And that is why it is called a zero sum game. Do you guys remember the game tree that I showed you in the previous video? This particular game tree is created by initial state. The set of actions that any player can make is represented by all of these leaf nodes. The final state or the terminal state minimax algorithm is used by AI and hence from wherever AI begins is taken as a start point and becomes the current state. Human beings do not need AI as we use our brains. So let's look at this minimax pseudocode. So this minimax, where S is the current state of our game, first it will run the terminal function. This terminal test will determine if the game is over or not. If the game is over, it will send the utility of the current state. That means it will send the utility of the player who played the last state back. So, for the given current state, there will be a utility set that will decide whether it will be a plus 10 or minus 10 or a 0. If it is not the terminal state, that is when you need to apply the actual minimax function. The second line in the algorithm is for when the player of the current state is the max player. You know who the max player is, right? It is none other than the artificial intelligence. So, if the player is max, then it will go through all the actions that are available for the current state of the code. That is represented by the action of S list. So, it will create the action of the list based on the current state of the code. And then it will go through all the actions where every A is every single action. So for every single action, it will call the minimax function again. It will run the minimax algorithm again for every possible action. If the action of S list has 5 different actions, then this minimax algorithm will run another 5 times. A new game tree will be created and then we will run the function again, and inside it will send the result of S, comma a value, and we are going to return everything to minimax. It will again check if the terminal state has arrived. If not, it will move to the next step and check if the next player is max or min. If the last player is max, next player is going to be min. And it is again going to create a list of actions it can perform right now. And then for all those actions, it is going to call the minimax with the result that is going to be the next state. Finally, all the actions will be exhausted as you see the result of S, A here. Once we reach the terminal state and get the utility for the current run of the minimax function, that utility value will be stored and that will be the result of the minimax. So, wherever we get the utility as positive or a win for the max player, we will trace back that tree and ask the player to make that move. That is what this line of code represents. So the same thing will happen if the player is a min player. So this might have been a little or a lot confusing. So let's understand all of this with the tree we drew before. When we understand it with a tree, you will understand what the code actually means. In this diagram, we are running the minimax function with the current state of the board. So we call the minimax on this particular current state marked in green. Minimax function draws the game tree with the current state of the board and the actions that it can perform in this particular current state. So these actions are represented in the branch of our tree. Minimax is called a recurring function as it keeps calling itself again and again. First action is the left tree and we make that. When the player is min, and we run the third of the line of the pseudocode that is corresponding to the min player, as the above two statements in pseudocode will return false right now. The third line asks us to get to the next set of actions, and that is depicted in the pink code. It is called the minimax function again. Next is again the max player turn. So minimax function will call again and the second line of code is run. It asks us to run the minimax function with the current state, which is only 3 nodes now as depicted in the blue square. These 3 nodes are now the new game tree for the current state. Now what will happen? We have reached the terminal state and there is no more branches in here. So the terminal test is run true right now. So it takes our utility and utility here is 3. Now it will send the result back through the loop. Based on this feedback, max function at the root will choose the left node as its optimal result. That is the optimal move if the AI is going to win. That is how we use the minimax function. We just saw an example with a very simple algorithm. This obviously gets complicated as we move further to the game with more than 2 nodes to start with, as in tic-tac-toe that has 9 nodes and chess that is even more complicated. We will take example of minimax algorithm in our next video. With this, we draw to the end of this session. I hope you enjoyed the video. Do like, share, and subscribe, and continue to watch our AI series.